Okay, so good morning all. Today we're going to continue with chapter 9. So we have seen how to derive the equations in our previous class. So today we're going to continue with exercise 2. See how to apply the equations that we derived last week. So let's see now. Exercise 2, questions 1. A large motor in a factory causes the floor to vibrate at a frequency of 10 hertz. So again, you are given frequency. So if you remember the things that I told you in our previous lesson, frequency, omega, and period, they are one big family. So if you are given one of them, you'll be able to determine the value for the other two. So now we have frequency. Let's see what are we going to do with this frequency after this. So the amplitude of the floor's motions near the motor is about 3 mm. So you are given amplitude. Estimate the maximum accelerations of the floor near the motor. So you have F, which is 10 hertz, and then you have A, which is 3 mm. Question asks you to determine the values of maximum accelerations. So from the table, from the summary table that we constructed on a Monday, we have A maximum is equals to A omega squared. Okay, so you're given F and A. A is not in SI unit. So if you want to calculate acceleration, it will be better if you convert it into meter. So A is equal to 3 mm. So it is equal to 3 times 10 to the power of negative 3 meter. Okay, so we are given F. We want omega. So what are we going to do? So we need to calculate omega. So omega is equals to 2 pi F, which is then equals to 2 pi times 10. So it is 20 pi radian per second. So radian per second is SI unit, and then A in terms of meter is SI unit. Now both of them are in SI unit, therefore we can then calculate the maximum accelerations of the motor. So it is equals to 3 times 10 to the power of negative 3, and then times 20 pi. So the final answer is 11.84 ms negative 2. Okay, so that is our final answer. So remember, whenever you are given frequency, so the function must be either for you to calculate omega or period. Okay, so omega, we use it in equations. So this one, we use it in equations. Period, we use it in a graph. Right? So we use period for graph. We use omega for equations. Okay, so that is our questions 1. So I give you 1 minute to write it down. This is just a very simple questions. Okay, it's just to see whether you understand the questions or not, whether you know the functions of frequency or not. Right? So 1 minute for you to write it down. So if you are done, you may try questions number 2 first. See how are you going to calculate velocity from the equations given. Okay. Now, questions number 2. So this is questions, okay, where you are given the displacement, okay, the displacements of particles, and then it wants you to calculate different types of velocity. So the displacement x of a particles undergoing linear simple harmonic motion is given by these equations. Now, if you remember, what did I tell you on Monday? Okay, whenever you're given an equations, okay, and equations, what are you going to do? Always compare it with general equations. So you have x equals to 5 sine 20 pi t Therefore, the general equations that we're going to use in this question is x equals to a sine omega t. All right, so by comparisons, the informations that we have is a is equals to 5. So 5 what? 5 cm, because it tells you x is in terms of cm. Okay, they are being measured in cm. So a is equals to 5 cm, and your omega is equals to, okay, omega is equals to 20 pi. Okay, 20 pi radian per second. Okay, 20 pi radian per second. So how do I know that it's a second? Because it tells you t is measured in second. So it's radian per second. All right. So if t is measured in minute, then the omega would be radian per minute. So what is the maximum speed? So maximum speed is also your maximum velocity, all right? So maximum speed, what is the maximum speed the particles can achieve? So V max, okay, according to the table, V max is equals to A omega. So now you have A, you have omega, you can then calculate the V. Okay, so if you look at the answer given, it gives you in terms of cm. Okay, but I would suggest you to write it in meter. Right, so 5 times 10 to the power of negative 2 meter. So you have a 5 times 10 to the power of negative 2 times 20 pi radian. So the answer is 3.14 meter per second. All right. So that is questions 1. Okay, that is questions 1. And then questions B. Determine the magnitudes of velocity and accelerations when the particle is 3 cm from equilibrium positions. So how are you going to calculate it? Right? How are you going to calculate it? So you are given x is equals to 3 cm. Okay, 3 cm. So, well, if you are given x, okay, if you are given x, so what are you going to do? You are going to use the equations, okay, the equations with x. So let us go back to the table. So if you look at the summary tables that we constructed on a Monday, okay, you have the table where it shows you the equations with t and also with x. Since you are given x, it means the equations that we're going to use is the equations with x. So you have v equals to plus minus omega square root a square minus x square. And then you have a equals to negative omega square x. So this is the equations that we're going to use. All right, this is the equations that we're going to use. Okay, so now let us go back to the questions. So determines the magnitude of the velocity. So it's asking for magnitude, therefore you can ignore the negative sign in your equations, all right? Because it's asking for just the magnitude, just the value without direction. Therefore, you can ignore the sign convention in your calculations. If you use sign convention in your calculations, then remember to add one sentence at the end of your calculations. So V is equals to, okay, now let us keep the equations. Let us keep the sign convention. So V equals to omega plus minus omega square root a square minus x squared. Okay, if you use everything in terms of cm, then make sure your final answer is in cm. So it is equals to 20 pi square root, okay, plus minus 20 pi square root 5 square minus 3 square. Therefore, okay, since I'm using a and x, both of them, they are in terms of cm. So final answer, I can write it in terms of cm. 251 cm as negative 1. Right? So if you already convert them into meter, then the final answer is just 2.51 meter per second. Okay, so remember to write one more sentence. The magnitude. Okay, the magnitudes of V is 251 cm as negative 1. So write one more sentence without the sign convention. Okay, because the question is asking for magnitude. Remember, when the question is asking for magnitude of a vector, then you just ignore the negative sign in your final answer. All right. So next one. So the equations for A is A equals to negative omega square x. All right. So it is negative. Okay, so 20 omega is 20 pi square, and then the x given is 3. So if you calculate it, it will be negative 1.18 times 10 to the power 4 cm as negative 1. So remember to write one more sentence for the magnitude and then change the answer into a positive value. So the final answer is 1.18 times 10 to the power 4 cm as negative 1. All right? So rewrite it in a statement form and then ignore the negative sign. Okay, ignore the negative sign. So that is the answer for questions B. Now, how about question C? So question C, question asks you to determine the initial speed when the particles start to undergo a simple harmonic motions. So initially, okay, what happens? Initial speed, it happens at t equals to 0. Right? So in which it means you are going to use t equals to 0 in your calculations. But now the questions would be, you are not given the values, the equations for v. So what should you do? Well, if you look at the questions, okay, if you look at the questions, you are given the equations in terms of x. And we know v is equals to dx over dt. So which means you need to know how to differentiate the equations. So v is equals to dx over dt. It is equals to d over dt, bracket, substitute the equations for x into the equations. So I have 5 sine 20 pi t. Okay, so now I'm going to differentiate this whole thing. So for those of you, if you are not used to differentiate with value, then what can you do? You can differentiate the equations. Okay, what you can do? You differentiate equations. So v is equals to d over dt a sine omega t. So that is what you can do. All right, and then after you differentiate it, then you plug in the values of a and omega in your equations. All right. So if you are not used to differentiate equations with value, then you can do it in the equations form. Okay, the one on the right hand side. So let us continue. So differentiate 5 sine 20 pi omega t. What am I going to get? Well, I will keep the 5 here because 5 has nothing to do with the time. So I differentiate sine 20 pi t. Differentiate sine 20 pi t. Now I have 20 pi here. And then differentiate sine, it becomes cos. Okay, so you have a cos, and then cos 20 pi, I have 20 pi t. Okay, 20 pi t. Okay, wait, yeah, let me go back to something. Oh yeah, I made a mistake last week, yeah. Wait, yeah, let me see. Okay, I differentiate. Oh yeah, that's correct. So sine, cos, negative, yeah, true. Nothing. So all right. So now I differentiate sine, I get a positive cos. Okay, you differentiate sine. Let us do a quick revisions. So if you differentiate sine, you will get cos. You differentiate cos, you get negative sine. All right, so this is the thing that you need to remember because you need to do the differentiations in the exam. So now I differentiate sine, I get cos. Okay, so the final equation for v is 5 times 20, I have 100 pi cos 20 pi t. So that is the equations for v. So what am I going to do next? Well, because you are talking about initial, so initially we are going to assume t is equals to 0. So at t equals to 0, v is equals to 100 pi cos 20 pi times 0. Okay, which means cos 0. So cos 0 give you 1. Basically, you just have to calculate 100 pi. So it is equals to 314.16 cm as negative 1. All right. So the equations, okay, whether you're going to use a cm or meter, it depends on the unit for A. Okay, if A is in terms of meter, then you use a meter in your final calculations. So, final answer. If A is in terms of cm, then you use cm in your final unit, okay, in your final answer. So that is how you solve question C. Okay, so questions A is very simple. Questions B and questions B and question C, it shows you the difference between situations given, okay, between when X is given and when T is given. If you are given X, then you use equations with X. If you are given time, then you use equations with time. All right. So now I give you 2 minutes to write down the answer. Make sure you know what is the difference between questions B and question C. Okay, questions B, you are given the values of X. Question C, you are given the informations at initial, which is T equals to 0. All right, initial, we often assume T is equals to 0. So 2 minutes for you to write down. If you have any questions, you may ask. All right. So just make sure you know how to differentiate the equations, because sometimes the questions will give you equations in terms of cost. All right, X in terms of cost. Then if that is the case, then you need to know how to differentiate the cost function. Okay, so next. Okay, next questions. Next question, you need to know how to form equations again. So now let's see. A particles undergo simple harmonic motions with a period. So you are given T. Okay, so you're given T. So you need to know what is the functions of T. So an amplitude of a 5 mm. So this is an amplitude. Now, the important information is in the next statement. Its displacement at times T equals to 0 is 0. Aha. So this statement is very important, okay? You need to know what happens when times T is equals to 0. So according to this statement, at times T equals to 0, X is also equals to 0, okay? And after that, it moves to the right. Determine the displacement of the particles at times T equals to 0.15 seconds. Now, you are given time. It means you need to use equations X with time. All right, since times is given, you need to use equations for x with t. So how to solve the questions? Now, you're not given any equations, right? Which means you yourself have to form the equations with the informations given. So what is the general equations for x? So x is equals to, well, you have a x, so a sine omega t plus phi. Okay, a sine omega t plus phi. So what are we going to do? First of all, we need to see what is the information that we have. We have a, but we don't have t. We don't have omega, sorry. We don't have omega. So what can we do? So we have a is equals to 5 mm. Omega can be calculated by using period. Therefore, 2 pi over t, it is equals to 2 pi over 0.4. Therefore, omega is actually equals to 5 pi radian per second. But again, if you look at the equations, we have a, we have omega, but how about initial phase angle? We don't have initial phase angle, right? But what we do know is at times t equals to 0, okay, x is equals to 0. So what we can do right now, we are going to sub all this value into our equation. Okay, we're going to sub t, x, a, and omega in the equations to find out what is the value for phi, initial phase angle. So x is 0 equals to a, it's 5, sine omega is 5 pi t plus, okay, t is 0, sorry. Okay, you have a time small letter t is 0. So this one is 0 and then plus phi. So rearrange the equations, okay, for these questions, you will get phi is equals to 0. So which means it tells you, okay, which means in these questions, the simple harmonic is start from the equilibrium position because initial phase angle is 0 radian. Okay, 0 radian. So the reasons why I show you this step is because sometimes the object, it won't start from 0 and it also not start from amplitude. Okay, it does not start from amplitude, it does not start from equilibrium position. So you yourself have to find out what is the initial phase angle, where is it, okay, where does it start. So this is how you find out, okay, the initial phase angle, the positions of the initial phase angle, initial position. So after you find out what is the values of phi, then we can proceed to equations. So now we know x is equals to phi sine and then just 5 pi t without initial phase angle. Okay, so this is our general equation. The general equations that we construct based on the informations given. So now let's proceed to solve the question. So determine the displacement of particle as time t equals to 0.15 second. So at t equals to 0.15 second, x is equals to 5 sine 5 pi times 0.15. Okay, so therefore it is equals to 3.54 mm. So the reasons why I know it's in terms of mm, it's because my a is in terms of mm. All right. So x and a, they share the same unit. Okay, they use the same unit. If a is in terms of mm, then x is in terms of mm. If a is in terms of meter, then x is in terms of meter. All right. So that is the final answer. So this is how you solve questions A. All right. Quite often, students, they forgot to calculate the initial phase angle. All right. You need to show it. Okay. You need to show it. So initial phase angle, you calculate by using the informations at initial position. What happens at times t equals to 0? Usually that information will be given in the questions. Okay, so biasanya apa yang pelajar terlupa buat, dia terlupa kira initial phase angle. So anda kena kira, okay, anda kena kira. So once you got an initial phase angle, then you can proceed to forming the equations. So that is questions A. Now questions B again, same as questions 2, okay, same as previous questions. You are given time and question asks you to calculate velocity. So you need to use equations for V with time. So you have general equation x equals to 5 sine 5 pi omega t. So V is equals to d over dt bracket 5 sine 5 pi t. Okay, now you want to differentiate this equation. So if you differentiate it, what are you going to get? You're going to get 25 pi cos 5 pi t. All right, so this is the equations. So now that you have the equation, you can then proceed to calculation. So at times t equals to 0.15 second, V is equals to 25 pi cos 5 pi 0.15. Oh yeah, remember your calculator must be in mode radian. Okay, in mode radian. So the final answer is a negative 55.54 mm as negative 1. Okay, so the reasons that I know it is mm as negative 1, it is because my A is in terms of mm. Okay, my A in this question is in terms of mm. Okay, now, next questions. Okay, next questions. Questions ask you to calculate acceleration at times t equals to 0.15 second. So again, you are given time. If you are given times, then you need to use A with time. Okay, A with time. So what are we going to do right now? Again, well, we don't have the equations. But what we do know is A is equals to dv over dt. So which means now you need to differentiate the equations for velocity. So A is then equals to d over dt bracket 25 pi cos 5 pi t. All right. So if you differentiate it, okay, if you got it correct, then what are you going to get? You're going to get negative. Okay, why negative? Because if you differentiate cos, it will become negative sign. So negative 125 pi squared sine 5 pi t. So this is the equations now. Okay, the equations for A. So according to the question asks you to calculate accelerations at times t equals to 0.15 second. So at t equals to 0.15 second, my A is equals to negative 125 pi square sine 5 pi 0.15. Okay, so A is then equals to negative H7T02.35 mm as negative 2. Okay, as negative 2. So this is how you solve questions B and question C. And then the last one, it asks you to calculate determines the velocity when the particles is negative 2 mm from its equilibrium positions. So now you are given x. Okay, this is x. So what you need to do, you need to calculate V with x because you're given x. So what is the equations for V with x? Okay, now we have a V is equals to plus minus omega square root, okay, a squared minus x squared. All right. So according to the questions, initially it moved to the right. So right hand side is positive, left hand side is negative. So this negative, okay, negative 2 mm, it doesn't tell you the direction, right? So therefore your V could be positive or a negative value. So you need to keep the plus minus sign, okay? You need to keep the plus minus sign in your equations because you don't know the directions of the motion, the directions of the particles, whether it is moving away from equilibrium position or it is moving towards the equilibrium position. So you don't know whether the V is positive or negative. Therefore, you need to keep the plus minus sign in your equations. So we have a plus minus, omega is a 5 pi, and then square root, well, the A given is 5 mm, and then minus negative 2 squared, right? So the V is then equals to plus minus, plus minus, well, you try to see whether the answer is 77 or 72, okay? Because the answer scheme given is a 72. So you try to check, yeah, whether the answer is a 77 or 72. I'm not sure which one is correct. So plus minus 72 mm s negative 1, right? Mm s negative 1. You need to keep the plus minus sign because you don't know the direction, and question asks you to calculate velocity. Velocity must come with a direction. So you need to keep both, okay? Plus minus, because you don't know the direction, you just leave it. Okay, you just leave it. So that is your questions number 3, right? So now I give you, okay, so this question is a bit long. Okay. So I give you 4 minutes, okay, 4 minutes to write it down. I will continue again at 8:35, okay, 35 minutes past 8. So you can write it down. So if you have any questions, you may ask. If there's anything that you don't understand, you may ask. Okay. So now let us continue questions 4. Okay, let me zoom in first. Okay, so now make sure you know how to choose the right equations to use in your solutions in the questions. All right, if you are given displacement, then you use equations with x. If you are given time, then you use equations with time. So now questions 4. A 1.15 kg mass oscillates according to the equation. So now you're given equation, but be extra careful, yeah? You're given equations in terms of cos. So where x is in terms of meter and s in terms of a second. So determines the amplitude. So amplitude, well, if you compare these equations with the general equations, x equals to a cos omega t, then you'll find that a is equals to 0.65 meter, because the question tells you now your x is in meter and times is in second. All right, so you have the unit in the questions. Make sure you use the right unit. So frequency, so question asking for frequency. Again, always remember omega period frequency, they are one family. So question asking for frequency means that you can calculate it by using omega. So omega is equals to 7.4 pi radian per second. 7.4, sorry, without pi. Okay, so tak ada pi-nya, dah terbiasa dengan pi. So just 7.4 without pi. So 7.4 radian per second. So from here, I can then calculate f. So I know omega is equals to 2 pi f. Therefore, f is equals to omega over 2 pi. Okay, which is then equals to 1.178 hertz. Okay, 1.178 hertz. So now that I have a frequency, I have a, so I'm done with questions A and B. Question C, total energy. So total energy, well, if you look at the questions, I don't have K. So I'm not going to use the equations with K. I'm going to use the equations with omega. So E, you have just one equation. Okay, it doesn't depend on time. It doesn't depend on displacement. What it depends on? It depends on your omega and also the amplitude. So E is equals to 1 over 2 m omega square A square. All right, so you cannot use half KA square because you don't have the informations of a K. So we use 1 over 2 m omega square A square. So plug in the value, I have 1 over 2. Now my m is 1.15 kg. Omega, I have a 7.4 square. And then A given is 0.65. So for these questions, you need to make sure everything is in terms of SI unit. Why? Because you want the answer in terms of joule. So joule is the SI unit. So which means M, omega, and A, all three of them, they must be in SI unit. So half 1.15 times 7.4 squared times 0.65, the final answer is equals to 13.303 joule. Okay, 13.303 joule. Questions D. Questions D is asking for two different variables, two different items, which is kinetic energy and potential energy. So kinetic energy, K is equals to, now you are given X. This is in meter. Okay, you are given displacement. So you need to use equations with displacement. Okay, you need to use K with X. Okay, and also U with X. So K with X, I have K equals to 1 over 2 m omega square A square minus X square. So you plug in the value and eventually you will obtain 11.175 joule. Okay, whereas for U is equals to 1 over 2 m omega square x squared. Okay, so again, you plug in the value, eventually you will obtain 2.129 joule. Now, for this question, there's an alternative method that can be used to calculate U, okay, or calculate K. Why? Well, we know E is equals to K plus U and it is equals to constant. Right now, whenever you're looking at a constant, a principles of a conservation, either for energy, for momentum, okay, you need to make sure you add in this part equals to constant. The total is equals to constant. Okay, so for your assignment, make sure to include this one when you explain anything. Okay, when you explain anything by using the principle of conservations of angular momentum. All right. So quite a lot of you give me the equation, but you didn't say it is equals to a constant value. Then in that case, you're not using the right principle. Okay, you're not using the right principle. So if you're using the principles of a conservations of a maybe momentum, angular momentum, energy, or whatever, make sure you put it equals to constant at the ends of your equations. Okay, so this is the part that quite a lot of you that forgot to add in your assignment. Okay, so okay, done with the assignment. Now let's look at the equations. So you have two choice. Either you calculate K first, and then you determine U by using U equals to E minus K, which is then equals to, from previous questions, I have 13.303 minus my K, which is 11.175. Then you will obtain the answer. Okay, you obtain the final answer, 2.13 joule. Okay, either you calculate K first and then you determine U by using this equation, U equals to E minus K, or you can calculate U first and then you calculate K by using E minus U. All right, so it is up to you, okay, which combo you want to use. You can calculate K and U by using the equations in the red color. You can calculate K first and then you use U equals to E minus K, or you can calculate U first and then you determine K by using E minus U. All right, so you have three combo. So it's up to you which one you want to use. All right, so we are done with the questions 4. Okay, we are done with questions 4. Now I give you 2 minutes to write it down. So it's very simple. Just that for questions D, you have to be careful. It's up to you which combo you want to use. Okay, make sure you use the right combo. Okay, so last questions. Okay, last questions. Let's see how to solve the last questions. So last questions is very similar to these questions, yeah? So, okay, an object of mass 0.3 kg execute linear simple harmonic motions on a smooth surface at a frequency. So you have m, and then you have the frequency and also amplitude. So determines the energy of the system. So how to determine the energy? Well, you have frequency, you have A, you have M. So we're going to use E equals to 1 over 2 m omega square A squared. Well, if you look at the equations, okay, you look at the informations, the questions, you don't have omega, but what you do have, you have frequency. Okay, so again, you see you have frequency. So which means omega can be calculated by using frequency. So it is equals to 2 pi and then times 10. Again, you have 20 pi radian per second. Okay, radian per second. So now I can plug it into the equations. 1 over 2 times 0.3 and then 20 pi square. Okay, now A should be in meter. Okay, why? Because you want to calculate energy, you want the unit in terms of joule, you need it in terms of SI unit. So A must be in meter right now. So 0.05 squared. Okay, 0.05 squared. So E is then equals to 1.48 joule. Okay, 1.48 joule. So make sure your A is in SI unit. Okay, this one is must be in SI unit because energy is in SI unit. Okay, joule is in SI unit. Questions B, the potentials energy and the kinetic energy of the object, okay, when X is equals to 3 cm. So now you have X equals to 0.03 meter. You want to calculate U and K. So once again, you can do it by using the equations that I showed you in previous question. Okay, so U is equals to 1 over 2 m omega square x square, and then K is equals to 1 over 2 m omega square A square minus x square. All right, so you calculate it by using these two equations, or you can assume the system does not lose energy. So you can also use this equation, this relationship. All right, so if you calculate U first, then you can calculate K by using E equals to K plus U. If you calculate K first, then you can determine U by using E equals to K plus U as well. Okay, so this is how you solve questions number 5B. Okay, 5B. All right, so okay, so I give you 2 minutes, okay, to complete the questions. Okay, I give you, oh, actually we are done. Okay, actually we are done. So let's stop the recording first.